everyone. Today we're going to talk about how to solve absolute value equations. So it's going to be very similar to solving just regular standard equations. There's just going to be a couple of things we have to look out for and do along the way. So the first thing we need to remember is that the absolute value of any number is going to be a positive value. So for example, the absolute value of 25 equals 25, and the absolute value of negative 25 equals 25. So that's going to be really important because when I tell you that the absolute value of x equals 25, we don't know whether there's a positive 25 or a negative 25 inside of that absolute value. So as we're solving these equations, we're going to sometimes have to consider both of those options, both a positive and a negative value within that absolute value notation. Okay, so you'll see up here some steps listed. We're just going to kind of jump in with example number 1 and start with step 1 and go from there. So step 1 says that we need to isolate the absolute value symbol and everything inside of it. So isolate, if you recall, means to get alone or get by itself. So we need the absolute value to be the only thing on one side of our equation. So example 1, we see that it's already by itself over here on the left side. Okay, step 2, we're going to check for special cases. So that means we're going to check over here to see if we have a negative value. Because remember, when we take the absolute value of anything, it's going to yield a positive result. So if this says that the absolute value of x minus 100 equals negative 25, there would be no solution for our value, because there is no possible way that any absolute value would ever equal a negative. Okay, this is not a special case. Absolute value can indeed yield a positive 25. So when we find that, or when we check that and we know that we're good to go, we're going to move to step 3. So this is where we split into our two cases. We're going to have a positive case and a negative case. So this is what I was mentioning right at the beginning. We don't know if what's inside these absolute values is equivalent to positive 25 or negative 25, because regardless of the sign before we take the absolute value, our answer is always going to be positive. So we're going to split it into two cases, and we're going to say x minus 100 equals positive 25, and x minus 100 equals negative 25. Okay, it's at this point that our absolute value symbol goes away because we no longer need it to equal a positive value. We have our two cases. We're evaluating each scenario that could possibly be inside that absolute value. Okay, we're going to solve each of these separately. So I'm going to come over here and add the 100 to get x by itself. So this zeroes out, and I find out that x equals 125. And then I'm going to do the same exact thing over here on the other case. Zeroes out, and we find out that x equals 75. So what that means is either of these solutions, when plugged in up here for my original, either of them will yield a positive 25 for the answer. Okay, so if we were to check our work, if I were to plug in 125 minus 100, you get 25, and the absolute value of 25 equals 25. So that is a good solution. Okay, same thing over here. Absolute value of 75 minus 100 equals 25. So here, 75 minus 100 is negative 25. Absolute value of negative 25 is positive 25. Perfect. So we know by checking our work that both of these values are solutions. Okay, so that is step 5, check for extraneous solutions. Extraneous solutions are solutions that when plugged back in, don't work. So we can say don't work when plugged in. So this is a really important step. Not only do we sometimes have things work out algebraically, even if we don't make mistakes along the way, and they end up being extraneous solutions, but it also helps you find your mistakes when you actually make them. So in other words, when they're not extraneous. Okay, you can write your answer as two separate numbers in curly brackets. So you could put 125 comma 75 or 75 comma 125. It's really important that we put them in the curly brackets and not parentheses, because if we put them in parentheses, they're going to look like an ordered pair, like an X and Y value, and they're not. Both of those represent two separate X values that work in this equation. Okay, example number 2 is going to require a couple more algebraic steps along the way. So the first thing, when we go back to step 1, we want to isolate the absolute value. So we're isolating absolute value of 3y minus 2. So the first step we're going to take to do that is subtracting 8 on both sides. So we get absolute value of 3y minus 2 equals 1. Okay, now that that is isolated, we check for special cases. So absolute value of 3y minus 2 equals positive 1. So since that's a positive value, it is not a special case. So we're clear to move on to step 3. Okay, step 3, I'm going to evaluate or solve for my 2 cases. So this is where we lose our absolute value bars, and we get 3y minus 2 equals 1. 3y minus 2 equals negative 1. And I'm going to solve each of these separately. So I'm going to add the 2 and 3y equals 3. Divide by 3, and y equals 1. So this is one solution. Over here, we're going to do the same thing. So I get 3y equals 1. When I divide by 3, I get y equals 1/3. Okay, of course, we would want to plug both of these back in. I have already checked both of them separately, and they do both work. Neither is an extraneous solution. Okay, so you can write them in any order, 1 comma 1/3 or 1/3 comma 1. You want to put the curly brackets around them. Okay, let's look at example number 3. So this one's going to take a little bit more time to get isolated. I want to isolate just that absolute value bar. So I'm going to start by moving this +2 + 2, zeros out. I have -6, absolute value of -4m minus 5 equals 6. Okay, next thing we want to do is divide by -6 on both sides. So that cancels out. I get absolute value of -4m minus 5 equals -1. So I've got my absolute value isolated. We're going to do step 2. We're going to check to see if it equals a negative. Okay, when we come down here, remember, absolute value has to be isolated first, and it is. Now I see a negative number. Okay, we did not have a negative at the beginning. That does not matter. You can even start with a negative at the beginning. The only time you do step 2, the only point in the equation where it matters is when you have your absolute value isolated. So here, I cannot plug in any value to absolute value and come up with an answer that's negative. So at this point, we get to say no solution and stop working, because there is no possible way I could plug in a -1000 and get some random value in there and still not have an absolute value that equals a negative number. Okay, so anytime you have your absolute value isolated, you want to pause, check to see that it doesn't equal a negative value, and then proceed with your problem. And if it does equal a negative value, then you need to stop and say no solution. Okay, you'll see down here example number 5. Absolute value is isolated. You're already equaling a negative number. So this one we don't have to do anything on, and we already know that it's no solution. So for this final example, we're still going to follow the same 5 steps, but you see that there's variables on both sides. So this we're going to run into where we find our extraneous solutions. So on the left side, we see that our absolute value is already isolated. So our step 2 tells us to check to make sure that the right side of our equation is not negative. So in this case, it is not. We're going to proceed to step 3, where it says we're going to separate it to a positive and a negative case. So we have a plus 7 equals 2a plus 8. And then we have a plus 7 equals negative 2a plus 8. So we're going to make that whole entire right side negative. And we'll talk about how to deal with that in just a second. So we're going to go ahead and proceed solving this left side. I'm going to go ahead and subtract a on both sides. So this zeroes out. And then I'm going to subtract 8 on both sides. So this zeroes out. And I get -1 equals a. So we actually have an answer of a equals -1 on the left side. And then on the right, we're going to distribute out this negative. So I get a plus 7 equals -2a minus 8. I'm going to go ahead and solve it as I normally would. Subtract that a and 0 out, add 8, and we get 15 equals -3a. And then we're going to divide by -3 on both sides. We find out that a equals -5. So I've got my two solutions just like we have in the past. We're going to go back and plug these two solutions in. So let's start with our a equals -1. So I have the absolute value of -1 plus 7 equals 2 times -1. 2 times -1 plus 8. So we have the absolute value of 6 equals -2 plus 8. 6 equals 6, yes. So this first solution, a equals -1, worked out perfectly. So then we're going to plug in our -5. Okay, so I have absolute value of -5 plus 7 equals 2 times -5 plus 8. So I have absolute value of 2 on the left equals -10 plus 8. Absolute value of 2 is 2. -10 plus 8 is -2. That does not work. So therefore, a equals -5 is what we would call an extraneous solution. So it's something that worked out algebraically, but it is not a solution because our right side does not equal our left side when we go plug it back in. So we would say our solution for this, and I just write it up here at the top, is -1. We only have one solution, which is perfectly fine. And then we could label this a equals -5 as our extraneous solution. So that's why it's really important that we always go back and plug in our work, because we didn't make any mistakes as we worked through this example. But once we got to our final answers, when we went back and plugged them in, they did not work. So if you recall from Algebra 1, you could find your solutions to two different linear functions by graphing them and finding the point of intersection. So I'm actually going to do the same thing here with these two. I've already got them typed into Desmos. So if I flip over to Desmos, you see over on the left, I've got y equals the absolute value of a plus 7 and y equals 2a plus 8. So we see our absolute value, we see our linear equation from the other side of the equal sign. And we want to find out when these two values are equal. So you see that they only touch once right here. And if I tap that again, we see that it's at the point -1, 6. So at an x value of -1, both sides of your equation would equal a +6.